Of logarithms. Sorry. I imagined a theme song there. Welcome, ladies and gentlemen. That's right. Properties of logarithms is the theme of today. The first thing I want us to do is actually check this out. I don't know if this is an example or just a check this out is what I'll call it. But log base 2 of 8 times 32. That was an ugly 2. If I wanted to do that, I could actually rewrite both of these as powers of 2. 8 is what power of 2? 2 to the third. 32 is 2 to the fifth. And then I could add them up. Add them up. Add them up. Do, 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 do. I think all my songs are now exactly the same rhythm. It's terrible. And I get 2 to the 8th, right? Something like that. So log base 2 of 2 to the 8. Does anyone know what that's going to be? 2 to what power is 2 to the 8th? It's 8. Yeah, seems to make sense. Right? And check this out. What if I do this slightly different? It's a different problem. Let's see what happens. Log base 2 of 8 plus log base 2 of 32. So different situation, somewhat parallel, not perilous, but parallel to it. So log base 2 of 8, what's that going to equal? 2 to what power is 8? And 2 to what power is 32? 5, right? We did that up there. And 3 plus 5 equals 8. So it turns out, it appears as though there's some relationship between this expression and this expression. And that is going to be our first property, right? 3 plus 5 is 8, 3 plus 5 is 8. You see all that going down? It turns out this is the product property of logarithms. And product property, which says that log base b of m plus log base b of n, the sum of two logs of the same base is equal to the log of their product. Peculiar. It's a product property, I guess, of logs. It's kind of a C-ish L right there. L-O-G. And actually, there's a similarity that we've seen here before with properties of exponents. Right? When I multiply two things of the same base, I could add the exponents. We're kind of seeing a little bit of a similar relationship here. All right? So I can use this in a variety of different ways. For instance, what if I told you that log base 3 of 5, let's say we happen to know that, was 1.4650. And let's say I told you that log base 3 of 2. Let's do that one. Let me figure that out. Let's see. Log of 3 is 0.6309. And it makes sense for this one to be less than 1, because 3 to what power is 2? If 3 to the first power is 3, yes, bless you. Right, if 3 to the first power is 3, then 3 to the what is 2 would have to be less than 1, right? 3 to 1 is 3. 3 to what is 2? Right, something like that. And this one would have to be bigger than 1, because if, once again, 3 to the first power is 3, 3 to something bigger than 1 would have to equal 5. Something like that. But let's say, what if I wanted you to figure out what is log base 3 of 10? What if I asked you to find that based off of those previous facts? Well, you'd say, if for instance you didn't have a calculator, couldn't do this, you could say, well, log base 3 of 10 is the same as log base 3 of 2 times 5. And then you might say, well, using this property of logarithms, the log of a product is equal to the sum of 2 logs. So this would just be 0.6309 plus 1.4650. So 1.4650 plus 0.6309. I get log base 3 of 10 is about 2.0959. Just by adding them up. And this is a way that I mentioned yesterday, that logarithms are able to change multiplication to addition of numbers. All right, so it's kind of an interesting little setup here. So kind of an interesting little property. So we'll be able to use that to break logs apart, put logs together, different things like that. Now, what if, similarly, using the same facts, what if I wanted you to figure out what is log base 3 of 25? How could I use my previously stated facts? What's that the same as? Right, 5 times 5, and you were saying add 1.4650. 5 times 5, right? Yeah, exactly. Yep, you were both on the right track. So log base 3 of, you could call that 5 times 5. So that's just log base 3 of 5 plus log base 3 of 5, which is the 1.4650 doubled, right? So 2.93. That's what I get, 2.9300. Uh-oh. That's what my son Everett says when he drops something. He'll go, uh-oh. But he'll drop stuff on purpose. I'm like, Everett, you're using that word wrong. That's not how it works. You can just throw your food on the floor and then say, uh-oh. It's not an accident anymore. But for those of you on the internet, my son is less than 2 years old, so it's not like I have a teenager that doesn't understand the concept of uh-oh. Just to be clear. That'd be somewhat amusing. Well, or sad. Or sad. Now, alternate reality of this, another way I could have thought of that problem, I could have thought of log base 3 of 25, I could have thought of that as log base 3 of 5 squared. And that's the equivalent, right? There's nothing wrong with that. Those are the same. So this is equal to all of those. And also I want to point out that log base 5 plus log base 5, log base 3 of 5, my apologies, plus log base 3 of 5, right? So if this is equal to that, is equal to that, is equal to that, then these are equal to each other. That's called the transitive property of equality, if you didn't know. But what's another way I could write this? Log base 3 of 5 plus log base 3 of 5. That's the same as 2 times log base 3 of 5, right? It's kind of an interesting situation. So it turns out, how does this relate to this? Yeah, the exponent is now kind of the coefficient. Just to verify, what if I wanted to figure out log base 3 of 125? That's the same as log base 3 of 5 cubed, which would be log base 3 of 5 plus blah, blah, blah. There'd be 3 of them, right? And that's the same as 3 times log base 3 of 5. So once again, it seems like it would establish the pattern. There's some relationship between this and this. So it doesn't seem to be a coincidence. So that I would suspect that if I had log base 3 of 5 to the 20th, I could just rewrite that exponent of 20 as the coefficient. And that turns out to be the power property of logarithms that we've just discovered. Power property, logarithms. Which says that log base b of m to the p, all right, is the same as p times log base b of m. So basically, this is kind of cool. You can take your exponent and move it out front, which is kind of a really cool thing. And this is the property of logarithms that will allow us to get stuff out of exponents. All right, so if I'm trying to solve an equation that has a x in an exponent and I'm trying to solve for that x, this is how we're going to do it. We're going to be able to take the log and then move that exponent out front, and now I no longer have a variable in an exponent, and I can solve the problem normally. It's going to be pretty good stuff. And one of the things I want to point out, this is different than log base b of m all to the p. Okay, so that is not what that means. All right, specifically the m is being raised to the pth power. Pth. All right. So just to be clear, all right, subtle difference there. So that can have some interesting effects. I'm going to skip that example for now, I think. Power property of logarithms. And then let's see. Let's do one more property. And then we might get into solving today, which will be good. Suppose, using the same information from previous statements, what if I wanted to figure out what is log base 3 of, what if I wanted to figure out 5 halves? Now, this one's a little bit tricky, but this one maybe isn't so obvious. But I know that the log of a product from earlier, right, is equal to the sum of two logs, right? Log of a product, sum of two logs. So now I've got the log of a fraction. I'm dividing here. But there is a way that I could write that as a product. I could write that as log base 3 of maybe 5 times 2 to the negative 1. Right? 2 to the negative 1 is the same as dividing by 2. Do you guys agree? Right? It's like multiplying by a half. And let's see. So the log of a product is the same as the sum of two logs. So that's log base 3 of 5 plus log base 3 of 2 to the negative 1. And what property did we just learn a moment ago that would help us with this? What can I do here? Yeah, you got it. You got it, dude. That's what Michelle Tanner would say. So we could take that exponent and move it out front. So that's plus negative 1 times log of. Maybe we should just write it as minus. Right? Do you guys agree? It's minus. Okay, so could you perhaps find a relationship from this to this? Could you summarize what happened there? Well, if I had rewritten it like this, then I could go backwards and then go backwards, yeah. But let's see, what do we have? Here we had that the log of a product is the sum of two logs. So what could you tell me the log of a quotient is? The difference of two logs. So this is the quotient property of logarithms. Right? And I think there's a beautiful symmetry between these. And so let's see, log base b of m over n. Between these and properties of exponents. That'd be the difference of two logs. So yeah, notice the similarity. Properties of exponents, if I multiplied two things of the same base, I added, right? So when I multiplied two things of the same base, I added the exponents back in the day. When I divided two things of the same base, I subtracted the exponents, right? So notice that logarithms have similarities to some of our properties of exponents, is all I'm saying. So let's actually talk about some interesting things you can do with this. Let's talk about so some of these skills they'll have you do write as a single logarithm. Logarithm. And then they'll have something like this, where they'll have 3 times log base 2 of x minus log base 2 of 7, or something like that. If I want to write that as a single logarithm. Not yet. It turns out, well, I have to prioritize multiplication before I do subtraction. But you are right that eventually I'll be able to do the x over 7. But it turns out I can use my power property in reverse. Peculiar. So that's log base 2 of x to the third minus log base 2 of 7. And now I can use my difference of two logs property and write that as the log of a quotient. So log base 2 of x cubed over 7. And now there's written as a single logarithm. Good stuff, good stuff. Right, so that's a skill that's going to actually help us later in solving logarithmic equations, where we'll be able to relate it to something like this. So what if I just said straight up solve, and I had the following. 2 times log base 3 of 6 minus, oh, this one's beautiful, 1/4 times log base 3 of 16 equals log base 3 of x. Man, I love it when math gets to the point where you have more letters than numbers.
I don't.
Like I feel like, I don't know, there's just like a, yeah, like it makes you feel awesome, like doing math, where someone else would look at that and they'd just be like, what? And then like, you know how to do it. It's good stuff. Right? Yeah, it gives you confidence. You know what this means. It's a language that we're learning. Okay, so first of all, what I want to point out is when we solved equations on last night's homework, if I had a log equal to a log and their bases were the same, what did we end up doing? We just set their insides equal to each other, right? So if two logs are equal, their bases are the same, then their insides are equal, is what we said. Now the issue is, I don't have two logs that are equal. I've got this log equal to the difference of two logs. So my goal here is to write each side as a single log. The way I said single log, I could see myself messing that up and saying, as a sing-along. Sing-along. If only. So I want to rewrite this left-hand side as a single logarithm. The right-hand side already is its own logarithm, so that's cool. So how could I combine these as a single logarithm? Well, before I can handle the subtraction, I've got to deal with this multiplication. So I'm going to use my little whoop and whoop power properties and move those up top. Right? So this is going to be the same as log base 3 of 6 squared minus log base 3 of 16 to the 1/4. Right? If you were really clever or thought of it, it wouldn't matter actually. I don't know if it makes it any easier, but it's a matter of perception. You could have actually pulled the minus sign out with this quarter and then changed this to a plus sign and that make it negative, but that doesn't really matter. So let's see. I've got the difference of two logs, so what can I rewrite that as?
Excuse the interruption. At this time, log 1 is finished. You may pass to advisory. And all seniors at this time should be up in Miss Abraham's room for a class meeting. Thank you.
X equals 9, right?
So let's see. 6 squared is 36. The fourth root of 16 is 2.
Grade will also start at 9:40 to 9:55.
Right. And so, yeah, x is going to equal 18. All right. Well, thank you, ladies and gentlemen. I think we're good. So goodbye, Internet. And for my